Hi. Hello, everyone. Thank you for coming. My name is Milos Milosevic. I am from Nordies, and today I will be talking to you about Pushkin, our open source messaging system, which we developed primarily for sending push notifications. So before we start, I would like to tell you a few words about myself. I am a data scientist at Nordies, and my primary goals are data pipelines and the deployment and maintenance of machine learning models. However, I have also been a part of the team that developed Pushkin. In case you haven't heard of Nordies, we are an award-winning gaming company. We were founded in 2010 right here in Belgrade, and we have offices all over Europe in London, Dublin, and Belgrade. And also, we are the proud creators of Top 11. Now, I'm just curious. I want to see by a show of hands how many people in this room have either played or are playing Top 11 right now. Let's see, 1, 2, 3. Not bad. You have in your gift bags tokens for Top 11. So if you're not playing, just give them to the guys that are playing. They'll be very grateful. Okay, so to give you a little bit of context about Top 11, it is an online free-to-play football manager game. It is our flagship product. It has 6 years old. It is global. It is played in every country in the world. And so far, we have over 150 million registered users, which is, in my opinion, a really great feat. So how does the game work? When you register, you, of course, receive a football team, and you train the players, you tune the tactics, you can buy players, sell players, you have various competitions to compete in, you can play against your friends, and all of your competitions, which are the League, Champions League, the Cup, and Association Tournament, are in one season that lasts for 28 days. And at the end of that season, based on your league performance, you are either propagated to the next level or you stay at your current level. So the game has a lot of moving parts, and in order for a user to keep track of all the moving parts, we want to communicate with them constantly and to constantly give them context and information about what's going on in the game. So because of that, we tend to use push notifications a lot. I'm sure you all know what are push notifications. You probably get them every day. But just to be sure, push notifications are the delivery of information from a software application to a client device without a prior specific request from the client. And why is this great? Well, you have a whole channel of communication which you can use in all sorts of situations, and you can inform your users about all sorts of things. So, for example, Top 11 uses notifications to notify the users that their match is about to start. Or perhaps if they haven't watched their match, we will inform them what was the result. We will also inform them when the league starts or when somebody bids on their player, or if you're a new user, you will get tips and tricks on how to play the game. And so we tend to use this a lot. And that's a good thing, because if you use it properly, you can increase all sorts of metrics in your application. And when I say metrics, I primarily mean retention. Retention is, you can look at it as a percentage that tells you how many of your users that registered on a certain day came back to your application on some other day. So for example, the most popular retention metrics are day 1, day 3, day 7, day 14, day 30, 60, 90, and so on. To show you what I mean, I will give you a few examples. So this is the actual retention of Top 11, of our day 1 retention. And the vertical line you see is the point in time when we started using push notifications extensively. As you can see, from that point on, our day 1 retention has constantly gone up, up, and up. Same goes for our day 3 retention, and the same goes for our day 7 retention. Now you may be wondering, why is our day 7 retention boosted by 35% and our day 1 retention is boosted by 15%? I get that question a lot. Well, the longer a user stays in the game, we have more data on the user, and we can construct more meaningful messages for the user and attract him back in the game if we think he maybe stopped playing. Okay, so are there any questions so far? Great. So let's talk about what you're really here. Let's talk about Pushkin. So Pushkin is an open source free tool for sending push notifications. To give you more detail, it is a web service that is powered by Python's Tornado, an asynchronous networking server. It uses Postgres for its backend information about user that it stores. It's completely written in Python 2, and of course it's open source. It has an MIT license, so you can do with it whatever you like. But before I dwell more about the architecture of Pushkin itself, I want to talk to you about the road to Pushkin. I want to talk to you about how we got to making Pushkin and how our systems for sending push notifications evolved. So back in 2013, Nordeus realized that it wants to send push notifications in top 11. And because at that time, we couldn't really afford to have a team that would focus solely on that, we opted for using third-party solutions. Most notably, we used Parse. You probably heard of Parse. So we used them for some time, and they were OK. But we noticed that they were having issues with our scale. So as I told you, we have over 150 million registered users. We have a lot of users that log in every day. And basically, the third-party solutions that we tried didn't really have a pricing plan for us. And we always had to have some custom pricing plans made, etc. And at the end of the day, no one really satisfied our needs. So we said, OK, so it's not a problem. Let us have our own solution. Let us make something that will fit our needs. So a team was formed, and its purpose was to make such a system. And we opted for using Hadoop and Spark. So we already, of course, had a Hadoop cluster, and we already had some experience with Spark. So we thought, OK, this will be a breeze. This is very cool. It will be easy. It will not be a problem. And yeah, we then sat down and started listing various requirements that we want to fulfill, that the system needs to fulfill. So the requirements were this. We wanted to have modular design. And when I say that, I mean that, OK, we didn't want to just send push notifications. We wanted to send Facebook notifications, Chrome notifications, emails, whatever. We wanted to cover everything. We, of course, had to be scalable because we have a lot of users. And our most top priority requirement was to have on-time delivery. That was set in stone. Why? Well, imagine that your match is about to start. And you know that top 11 will send you a push notifications for when your match is about to start. And you wait, and you receive the notification, you click on it, you go to the game, and your match is already finished because we were late. So in a sense, if that happens, then we are betraying our users, which is something you never want to do. So we really focused on that. Our second priority was having near real-time notifications. When I say near real-time, basically it means a matter of seconds or a matter of minutes after something happens in the game. So for example, your match finishes, you haven't watched it, and we want you to receive instantly a notification about the match result. Or, for example, recently we have implemented a chat feature in the game. And when you're not online and somebody writes something on chat, we want you to receive that chat almost instantly. So that was our goal. Of course, we wanted to have a logging system, which was really extensive, because we wanted to monitor everything from performance, for various metrics, and of course, we wanted to know if something is wrong. And we also wanted to support A/B tests out of the box, because when you send a lot of push notifications, you want to test a lot of things about the message itself. We knew we want to make various iterations. So we wanted to support A/B testing. And one thing that I forgot to tell you is why we focused on Hadoop, why we chosen Hadoop, and it is because of top 11 server infrastructure. So top 11 has multiple servers that serve multiple users, but these servers they serve a set of users, and all these sets are disjoint. So even though the servers share data between themselves, they don't really have a shared database. So if you wanted to have all the users in one place, you don't really have them. And since we already collected data to our Hadoop cluster, we said, OK, this is perfect. We'll use that. So after a few months' work, this is roughly the system that we come up with. It was called the Nordifier, heavily influenced by our company name. And it had 4 major modules. It had the data loader, the scheduler, the sender, and the maintainer. The point of the data loader was, of course, to load the data. And we have divided data into 2 parts, static data and dynamic data. Static data was data that was to be read in every day, only once, and it was data that will never change for that day. The only downside of having static data was that when we were loading it in, it took about 30 minutes for Spark to load everything. But that wasn't really a problem at the start. And we also had dynamic data. That was data that was constantly coming in and that maybe carried information about the push notification. So the data loader would load data, and it would propagate it to the scheduler. Scheduler was the system that checked this data every minute, and basically its job was to prioritize between push notifications and to designate users who will receive push notifications. From that point on, the scheduler propagated the notifications to the sender, and the sender just sent them, of course. The most important module was the maintainer, and we were really careful when we made the maintainer, because the maintainer monitored the whole system. And this was important because when we finally shipped this to production, it was probably one of the scariest days in my life, because we had a live system that was able to cover our whole user base in a matter of minutes. So if something goes wrong, you probably won't stop it. You won't see it in time. So our maintainer had to be able to catch these moments, and at those moments it had to just stop them, stop the whole system, and notify us. So yeah, it was pretty So we released this, and it went smoothly. This was running for 2 years in production. It's actually still running now, but not to its full power. And as soon as we launched it, after a few months, we started to notice problems, both technical problems and non-technical problems. Our first problem was with Spark. So Spark is a great system, a really great system. It's fast, it's reliable, etc. But one thing Spark was not made for is to support a system that will run 24/7. That's simply not its job description. So what we experienced is the system runs fine for, let's say, 10 days, and then out of the blue, it just crashes. No warning, no special thing, nothing. It just crashes. And of course, we started with Python, with Spark 0.9. So of course, it wasn't really stable then, but it slowly matured. Now it's really good, but still it happens that the whole system crashes after some time of running. So the problem with that was, OK, it crashes, we restart it, it's not a big deal. But then every 10 days, you have 30 minutes of downtime because you have to load in the static data. And that's 30 minutes of your users not receiving push notifications. So that was a little bit annoying, but we said, OK, that's fine, it's not really a problem. Second issue we had with this system was that So this system was running on our most biggest cluster, our production cluster. And on that cluster, we also had a bunch of ETL jobs. And also, our data scientists work on this cluster, and they run different queries. And from time to time, someone runs too big of a query and crashes a node. And Spark should be reliable to that, should be not affected by that. But if that crash happens when Spark is doing a shuffle, the whole system crashes. So we were really annoyed by that as well, because that meant, of course, again, 30 minutes of loading time, 30 minutes of downtime, and users are not receiving no notifications. They're not happy. They're sending tickets to support. So again, we tried to fix a few things, tried to make it more stable, but again, we were annoyed by this. The third problem was when we simply had so much data flying around on the cluster at certain points in the day that the whole network became very slow. And when that happens, then nothing crashes, but everything runs slower. And as a result of that, we were missing our on-time delivery, which really was not acceptable. And at that point in time, we said, OK, this is simply not working. We have to make a new system. And those were only the technical faults. The non-technical faults are a little more subtle. But in time, we noticed that we spent too much time from an idea for a push notification to the actual push notification. Because we have the product team for top 11 that develops top 11, and then you have the team that develops and maintains the Nordifier. And when somebody wants to when a game designer wants to think of a new push notification, the product team has to implement some data for the server, and then we have to collect the data, implement the notification in Nordifier, and then send it. Usually that's not a problem, but sometimes the product team has better things to do, or we have better things, more higher priority things to do, and things get delayed. So game designers are not happy. So we had issues with that too. So we really wanted to make a new system and try to solve all of the problems I mentioned, which wasn't easy. So we sat down, we thought long and hard, and we finally came up with Pushkin. Of course, it wasn't named Pushkin back then. It was named Mini Nordifier, but I think Pushkin is a much cooler name. So what Pushkin really is, it's a web service that talks directly to our game servers. So there is no database in between. There is no data collection. There's no nothing. It talks directly to the game server, and the game server tells Pushkin what to send, more or less. It looks something like this. So on the left, this is the old system. So a bunch of game servers and data collection goes into Hadoop, and then from Hadoop to Nordifier. And the new way, every game server gets a Pushkin for itself, and then just communicates with that Pushkin, and Pushkin takes care of those push notifications. Much simpler. And we had luck because our game servers and all of top 11 clients already had a system that we could use. They already had we call them message events that they send and communicate with data collection. So this is the protobuf definition straight from the repo. Basically, all top 11 clients and all servers send this. And this is basically just a message that says, OK, this event happened to this user at this time, and then an optional number of parameters, and a message could have 0 parameters as well. So we thought, OK, why not use this? And let this be a trigger for a push notification. So that was the main idea that we had. So Pushkin now has 2 modes. We have something that's called a push notification mode, when they don't really receive a message like this, but they receive a much simpler message that says, OK, for this user, send this message. And we have the event mode that receives the message you just saw, and then what happens? Pushkin then performs a device lookup, which is basically we need to see if we have a device for a certain user, which we want to send something to. So when we find the device, if it's an event message, we find does that event message have a mapping for some actual push notification. If that is true, we check if that user received that push notification today already. If not, we send it. If yes, we check how many can we send these messages per day. And if we are not breaking the limit, we send it. What's cool about this is basically that now we have excluded ourselves from the equation. So nobody needs to ping us if they want a new push notification. They basically just implement something on the server, and it takes one line of code to send the message to Pushkin. Pushkin will receive it. It will already have a mapping, and it will just send the notification. Now, also, this device lookup is really interesting. In order to do this, we need to send a login event to Pushkin every time a user logs on to the server, which can be very heavy. And actually, this was a deal breaker with all sorts of third-party solutions because they couldn't handle the number of logins we have per minute. So we really need to make Pushkin very resilient to this. But actually, since we have many game servers and many Pushkins, it was not a problem. Okay, so when we made this system, we had two main concerns. One of them was scalability, because, okay, so we were moving from a very scalable system, which is Spark, to Python, pure Python, which is, of course, nowhere near that fast. And we were scared because we simply couldn't tell if the system would perform good enough. And we were also scared because of the Python GIL. So you probably heard what is GIL and know what is a Python GIL, but I'll just recap. So Python only allows a single thread to be executing in its interpreter space. And this is a language feature, and it is restricted by the GIL, which is global interpreter lock. So when you make threads in Python, they will actually not run on multiple cores in your CPU. They will just run on one core, and that's it. It's a language special. So we were sort of afraid by this, but turns out that this is not a problem at all, because in addition to threads, Python has something that it likes to call processes. So processes are basically, they look like threads, they feel like threads, they have the same API as threads, but they not act like threads in Python. They basically are separate programs that just get forked in your Python program, and they run on multiple cores. A slight downside of this is that you can't really access data like you could from a Python thread. So when you talk to these processes, it has to go through a data manager of sorts. In our concrete case, we used queues. So this is how Pushkin looks like a little bit under the hood. So again, you have your message servlets, which receive either push notifications or event message notifications. They basically just receive the message, wrap it around, send it to the incoming queue. And then you have these request processor threads. And actually, this is one request processor. So this first thread pool of threads just does this. So device lookup, message localization, because, of course, if you want the user to receive the message in his language, you have to have various different types of translations for each message. So these are the threads, not processes, threads that do that. So they do that. They basically find the message that needs to be sent based off the event, and then they propagate it to the appropriate queue. And we had different queues for Google and Apple for their services, because when we made this, we were still using the old Apple API, so that meant that we couldn't really batch messages for them, so we had to separate Google and Apple into two different queues and give them different processes because they don't perform the same operations. So after these queues, we go to the processes. And first version was with threads, because we thought, okay, but like sending notification is just an I/O operation, shouldn't be a problem. It performed badly, and then we switched to processes and everything started flying. So at first we were puzzled by that because we couldn't really understand why. But then we just thought, okay, but on this server we have like 40 cores and just a bunch of messages get sent in parallel. So actually that was the trick. That's why it's much faster. We gained, I think, 10 times boost. So Pushkin sent push notifications 10 times more faster with processes than with threads. And right now we are also working on switching the first thread pool with actual process pool, because the API is basically the same for threads and processes, so you can very easily switch from one to another. Okay, so I want to talk about now about the reason why we open sourced Pushkin, because this is the question I get a lot. So 1 year ago, I held a presentation right here in Belgrade at the Data Science Conference, which will happen this year as well, and I recommend that conference as well. And I held a 45-minute presentation about machine learning and data science, and I had one slide that mentioned Nordifier for a minute. And after the presentation, a lot of people came to me, and they didn't ask me questions about data science or machine learning. They asked me questions about Nordifier and push notifications. And one guy even asked me if his company can pay Nordius to use Nordifier, which was very strange to me. So that night I went home and I Googled if there are any free solutions for push notifications. Because in my opinion, they shouldn't be a rarity, they should be a commodity, and everyone should have them. And actually at that time, that was November, I think, 2015, there were no free push notification services. If you want to send a push notification, you will have to read a lot of documentation, write your own code. It's probably not something a lot of the companies want to do. I mean, even Nordius didn't want to do that at the beginning. So also around that time, we were developing, or we were very close to finishing Pushkin. So we thought, okay, why we just don't open source this? Because in the gaming industry, push notifications aren't really something new. Everybody has them already, so it's not like we'd be like giving our secret sauce to our competition or anything like that. And we believe it will help a lot of the indie guys and a lot of other companies that simply don't have push notifications yet, and there's no reason for them not to. And I'm really happy to say that now, not only we have open sourced our solutions, but also some of the other guys have as well, and that is really, really great. Okay, so let's talk about the Pushkin roadmap for the next few months. Our first task is to make a centralized Pushkin. I know what it sounds like. You're probably thinking, wait, but you just escaped from a centralized solution. Why are you doing this? It's not what it sounds like. Basically, top 11 infrastructure is specific, and not a lot of games have that infrastructure when you have a lot of servers, and those servers each serve only a small group of users and only them. And so it was really easy to deploy Pushkin for top 11. But some of our new games and the games of other people don't follow this infrastructure. So, for example, if you have a third service that is not your game server, and that third service wants to send a push notification to a certain user, the problem you have is that service doesn't really know to which Pushkin it should speak, because each game server sends login information to its own Pushkin based on people who log into that server. And if your servers are disjoint sets, you don't know which server to address. So this is an issue. And we're planning on having multiple Pushkin instances work on the same database. We're currently working on that, and we want it first to work on our top 11 data, and when it works in full speed, when it can serve our whole user base in a matter of minutes, then we'll know that we can ship it and merge it with the open source project. Right now, we are frankly having some issues with Postgres, and we are thinking of just using some other database. We'll see which one. Okay, so when we do that, we will then upgrade PN library, because we still use the old one. Top 11 still uses the old one. We didn't really have time to switch. Basically, nothing will change when we do this. We'll just have more data about our users. We will actually know when you cannot send a message to someone because the user has deleted the application. We currently know that for Google users. We don't know that for the Apple users, and we'll change that soon. The third thing we'll do once we finish the APN library is basically implementing all of the things we already had in Nordifier. That means Facebook notifications, emails. We'll implement some new stuff such as Chrome notifications, and we are really open to suggestions on what should we implement next. And the fourth thing is a dashboard that can sort of unify all of your Pushkin services into one place, and where you can read off all the metrics and all the things you want. This is actually, in my opinion, maybe the biggest issue of Pushkin so far, at least for top 11, because we have so many instances. It's very hard to track off all the logs and all the things, and then when somebody comes and wants to send a notification to a certain group of users, and that's hard because Pushkin is a dynamic service. So there's no support for telling Pushkin, hey, just send these notifications to 100 users. Luckily, we developed a system for that. We called it heuristically Feather. We didn't open source that because it's very simple. I mean, you can do it in 15 minutes. Basically, all you need to do is have a system that you query any of your user databases, and then when you have the users, just send HTTP request to Pushkin, and that's it. You have instant static push notifications. Okay, for more information on Pushkin and for detailed documentation, instructions on how to install it, etc., I urge you to visit the pushkin.io website. And I would like to thank you for your time. And if you have any questions, feel free to ask them now. Thank you.
Hi. Hi.
Hi.
Does Norders have plans to make Pushkin to be like software as a service, maybe, or that's a bad?
Not really. Basically, we don't want to maintain it for other people. To explain shortly, that's why we open sourced it in the hopes that people will take it and make it their own. So, yeah. Yes.
Two quick questions. First, why Python?
Let me switch here so I can hear you better.
Okay, so first, why Python?
Okay. Well, actually, we weren't using Scala Spark. We were using PySpark. So we had a lot of code which could be used in Pushkin as well. So basically, that's why. And our data engineers feel most comfortable with Python currently. So that's it.
And actually, the main question is, how fast can I spin, like, on my box, Pushkin to send push notification to my phone? So just like a testing purposes, or a hackathon or something.
So your question is how fast, how many notifications can I send you per second?
No, it's just how fast can I go from never actually opening GitHub to setting up push notification on my phone?
I'm sorry, you have to repeat.
Okay.
I can hear you.
So I open Pushkin GitHub, I download the code,
Oh.
I don't know Python, I want to send one push notification to my phone. How fast can I spin everything up? And yeah.
Now I finally heard you. Well, it basically depends how good you are with reading documentation, because in theory, it should be very simple, but you will have the trouble of setting up Postgres. So that can be an issue. However, of course, we are really responsive on support side. So you have, of course, a Google group, which you can ping with emails, and we'll respond very fast. So in theory, it shouldn't be hard, because you can download code from GitHub, or you can just type pip install Pushkin and it will work. But you have to have Postgres pre-installed. And yeah, if you have it, then it's really in a matter of minutes. Cool, thank you for the question. Any other questions? Cool. Thank you, guys.